Hello everyone, welcome to Mediverse Atlas. In today's video, we are going to talk about the neuromuscular junction and the neuromuscular transmission. So, we are going to discuss the structure of neuromuscular junction and the process which is involved in the transmission of nerve impulses. So, before entering deep into the concept, I want just to give a brief orientation which we are going to talk about. So, we have something called as presynaptic membrane, synaptic cleft, and a postsynaptic membrane. So the basic funda here is when action potential arrives, when the action potential reaches the presynaptic membrane, there will be some changes occurred in this presynaptic membrane and there will be release of neurotransmitter into the synaptic cleft. With the help of this neurotransmitter, there will be contraction in the postsynaptic membrane. The postsynaptic membrane is nothing but the muscle fiber. So this is what we are going to talk about in this video in detail. So let us talk. First, what is neuromuscular junction? This neuromuscular junction is a specialized chemical synapse between a motor neuron and a skeletal muscle fiber where impulses are transmitted to initiate muscle contraction. So it's a chemical synapse. Okay, that is, some chemicals are involved in this, and it is between a motor neuron and a skeletal muscle. Okay, a motor neuron and a skeletal muscle where impulses are transmitted to initiate muscle contraction. From where to where the impulses are transmitted? From motor neuron to the skeletal muscle, the impulses are transmitted, which results in the contraction of this particular muscle. Now, this neuromuscular junction has three main parts. It has a presynaptic component, a synaptic cleft, and a postsynaptic component. This presynaptic component is nothing but the terminal part of alpha motor neuron, or it is also known as axon terminal. We'll be discussing the type of neurons in the upcoming videos. For now, remember, this terminal part of alpha motor neuron is nothing but the axon terminal, which is involved in this neuromuscular transmission. And the presynaptic component, it contains of synaptic vesicles which are filled with acetylcholine. This acetylcholine is a neurotransmitter. Okay, and it also contains mitochondria which provides ATP for the synthesis of this acetylcholine, and they also contain voltage gated calcium channels. And the most important point to remember here is when axon comes close to the muscle fiber, it loses its myelin sheet. Okay, suppose this is a muscle fiber, this is an axon. The axon, the whole length is covered by myelin sheet. As soon as it is in the way of approaching the muscle fiber, it loses its myelin sheet. So this is the important point. We can see in this diagram. So this is the presynaptic component. Basically, this is the presynaptic component. It contains the synaptic vesicles and mitochondria, and this mitochondria helps in the synthesis of acetylcholine, and this acetylcholine is synthesized or stored in the synaptic vesicles. So this is about the presynaptic component. Now we'll be talking about the synaptic cleft. The synaptic cleft is a narrow space which is about 20 to 30 millimeters, and it is a space between nerve terminal and the muscle fiber, and this contains basal lamina. Remember, basal lamina is nothing but the extracellular fluid or the extracellular matrix. Okay, and the synaptic cleft, it contains an important enzyme called as acetylcholine esterase enzyme. Okay, we'll be talking about the significance of this enzyme in this video after some time. So this is the synaptic cleft. The synaptic cleft contains the basal lamina, that is nothing but the extracellular matrix, and an important enzyme, the acetylcholine esterase. Now we are going to talk about the postsynaptic component. This postsynaptic component is also known as motor end plate. So it is a specialized region of muscle fiber. This muscle fiber is also called as sarcolemma. Okay, so it is a specialized region of sarcolemma where a motor neuron communicates with skeletal muscle fiber to produce contraction. Okay, I hope you are clear with this. Now this is characterized by the junctional folds. These junctional folds are also known as subneural clefts or palisades. They increase the surface area. And one more most important point to remember is the postsynaptic component. It contains numerous nicotinic acetylcholine receptors. We'll be looking at the diagram here. You can see here, these are the subneural clefts and these are the nicotinic receptors. Okay, So in the presynaptic membrane, we have mitochondria, synaptic vesicles. In synaptic cleft, we have acetylcholine esterase. In the postsynaptic membrane, we have the receptors. Which receptors? Nicotinic acetylcholine receptors, and of course subneural clefts. Now we'll enter into the important topic, the neuromuscular transmission. So in this neuromuscular transmission is the process by which nerve impulse is transmitted from motor neuron to skeletal muscle fiber at neuromuscular junction, leading to the muscle contraction. So okay, so we'll be discussing the process, how the impulse is traveled and how muscle is contracted. First, events. What are the events occurring at this neuromuscular transmission? So there are totally 5 events. So these are release of acetylcholine, action of acetylcholine, development of end plate potential, development of miniature end plate potential, and destruction of acetylcholine. So this is a simple process. We'll be talking it. So first is the release of acetylcholine. How this acetylcholine is released? Basically, in the presynaptic membrane, there are some synaptic vesicles. As we have spoken, these synaptic vesicles contains the acetylcholine. So this acetylcholine must be released into the synaptic cleft for the muscle contraction. Now, how does this process takes place? So, action potential, when it arrives the presynaptic nerve terminal, it causes the depolarization. Due to this depolarization, the calcium voltage gated channels which are present on the presynaptic membrane gets opened, and there will be rapid influx of calcium. So due to this rapid influx of calcium, it causes the bursting of synaptic vesicles and fusion of vesicles with presynaptic membrane. So basically, as there is influx of this calcium helps these synaptic vesicles to bind to the membrane of the presynaptic membrane. Okay, now this calcium gets influx and there will be binding of this synaptic cleft to the presynaptic membrane, and there will be bursting of this. As soon as the synaptic cleft gets burst, there will be release of acetylcholine. So this release of acetylcholine takes place, and now this acetylcholine must be get released into the synaptic cleft. How does this takes place? By the process known as exocytosis. See, I'll just give a clarity again. Calcium gets influxed, the synaptic vesicle binds to the presynaptic membrane, there will be bursting and release of ACH, the acetylcholine, and through exocytosis there will be release of acetylcholine into the synaptic cleft. Now, action of acetylcholine, the second step or the second mechanism. So there will be entry of acetylcholine into synaptic cleft, and acetylcholine molecules bind with the nicotinic receptor present on the postsynaptic membrane. Now, after the binding of these acetylcholine with nicotinic receptors which are present on the postsynaptic membrane, there will be formation of acetylcholine receptor complex. Okay, formation of acetylcholine receptor complex. Now, the formation of end plate potential. As discussed, acetylcholine receptor complex, it causes the opening of ligand gated sodium channels which are present on the postsynaptic membrane. Okay, postsynaptic membrane, they also contain some the Na plus ligand gated channels. Due to the formation of acetylcholine receptor complex, there will be opening of these ligand gated channels, and there will be rapid influx of sodium from the extracellular fluid, which generates a potential known as end plate potential. I hope you are clear. Okay, acetylcholine receptor complex causes the opening of ligand gated sodium channels, and there will be influx of sodium which causes the generation of end plate potential. Now the fourth point is development of miniature end plate potential. What is this miniature end plate potential? How it is generated? Miniature, small potential basically. Now, even at rest, the synaptic vesicles occasionally release acetylcholine. Okay, so which generates a weak end plate potential in neuromuscular junction, and its amplitude it is about 0.5 millivolts. And this miniature end plate potential, it cannot produce action potential in the muscle. Just remember about this miniature end plate potential. Okay, it is basically the release of acetylcholine even at rest. That is, even if depolarization do not occur, occasionally there will be release of acetylcholine into the synaptic cleft. It is the basic funda. Next, the fifth point is the destruction of acetylcholine. Now, acetylcholine released into the synaptic cleft, it binds with the nicotinic receptors and produce muscle contraction. Okay, Understood? As soon as the nicotinic receptors they bind with the acetylcholine, there will be opening of these ligand gated sodium channels, and there will be influx of sodium causing the end plate potential and resulting into the muscle contraction. Okay, now what happens to the remaining acetylcholine which is present in the synaptic cleft? So what happens is the remaining acetylcholine in synaptic cleft, it is rapidly destroyed to terminate the action. How is it destroyed? With the help of acetylcholine esterase enzyme. Okay, the remaining acetylcholine which is present in the synaptic cleft after the muscle contraction is destroyed by the acetylcholine esterase. It is destroyed as choline and acetic acid. This choline, it is taken up again by the presynaptic nerve by the active transport, and it is used in the resynthesis of acetylcholine, whereas this acetic acid, it gets metabolized. Okay, now here is a small summary. As soon as the action potential get, there will be cause of depolarization. Due to this depolarization, there will be opening of voltage gated calcium channels. These calcium channels gets open, and there will be entry of calcium ions from the extracellular fluid, and there will be opening of vesicles and release of acetylcholine into the synaptic cleft, and there will be binding of acetylcholine with receptor and formation of acetylcholine receptor complex. Due to this formation, there will be opening of ligand gated sodium channels. Due to the opening of these ligand gated sodium channels, there will be generation of end plate potential. Okay, and due to this development of end plate potential, there will be generation of action potential again, which causes the muscle contraction. We'll talk about excitation contraction coupling in detail. Okay, the process which is involved between this, we'll talk in another video. Okay, I hope you are clear with this concept of the neuromuscular junction and its transmission. If you have any doubts, please do comment in the comment section or DM us in the Instagram directly. Please do follow the Telegram for the more updates and notes. And thank you for watching. And please do subscribe, like, share. Thank you. Bye.